Hello guys, I'm Gaurav Hirani. Today I will be explaining about energy efficient aviation infrastructure. Let's start by looking at a quote. This quote has been quoted by Rosemary Adolino. It says, as the aviation industry plans for future growth, sustainability must be considered every step of the way. Advances in aircraft technology and sustainable biofuels will position our industry to reduce emissions while maintaining a competitive advantage. That is, we need to advance the aircraft technology and use sustainable biofuels to maintain a competitive advantage and reduce emissions. A small introduction. The use of sustainable aviation fuels and other potential alternative energy sources such as electricity, hydrogen, solar will be necessary to secure supply and further reduce aviation's environmental footprint in the long term. This will allow the extensive introduction of regionally sourced renewable energy close to airports, feeding both aircraft and infrastructure requirements sustainably. Now let's look at a small video, the history of aviation with energy. Energy has always been a major concern for aviation, not only for ecological reasons but in order to increase range and reduce cost. Since the 1960s, the commercial airlines have cut their fuel consumption by 70% and also reduced the CO2 emissions. Now that the emissions have become an issue for humanity, the aviation industry is well placed to find solutions. Already a passenger A380 uses just 3 liter per 100 kilometer passenger, and we can always improve on something that already exists. Future generation of aircraft will save fuel up to the last drop before moving on from fossil fuels. The need of change. Global warming is observed largely caused by human drivers. Commercial air traffic is increasing continuously over several decades. Between 1995 and 2005, an increase on average of 5.2% per year. Increased growth rates of greenhouse gas concentrations CO2, methane, NO2 during the last 50 years. Carbon dioxide increase caused mainly by burning fossil fuels. Contribution of air traffic to CO2 emissions worldwide is 2%. Now let's look at a small video explaining about the need of change in the aviation industry. The world needs transport fuels. Diesel is used in cars, trucks, heavy machinery and also ships. Diesel is also used in generating electricity in remote places and in factories. Jet fuel is used to power aircraft jet engines. Existing resources of oil and fossil fuels are rapidly decreasing. At current rate of consumption, the world uses 30 billion barrels of oil per annum. Sourcing this oil poses security and environmental challenges. As resources decrease and consumption increase, prices will continue to rise rapidly. As we have seen in the last video that we need to change something from fossil fuels to some biofuels. We need alternatives. So what should be the change? Firstly, reducing fossil fuel dependence. Like most types of transport, the aviation industry depends on fossil fuels. However, fuel supplies are becoming uncertain, more expensive, and cause environmental harm. In the last 40 years, aircraft fuel consumption and emissions have been reduced by 75% as the result of technological advances and positive steps across the aviation sector. Secondly, efficient fuel use. In order to meet the industry's eco-efficiency goals, aircraft manufacturers must ensure every drop of fuel is used efficiently and develop new ecological sound alternatives. Airlines already are seeing the benefits with jetliners like the double-decker A380, which only produces about 75 grams of CO2 per passenger per kilometer, well below the current and anticipated future international limits. However, there is always room for improvement. Now let us see some energy systems in airplane. Aircraft power sources. Bleed air power for cabin air conditioning, main engine start. Second, electrical power for lights and cabin entertainment. Third is hydraulic power for flight controls, for the wings to be controlled and the rudder, etc. See, from where does this power come from? The main power generating unit on aircraft are main engines, which are on the left and right side of the wings. It supplies around 1000 kilowatt. It supplies hydraulic, bleed air and electrical power for the aircraft. The second one, which is auxiliary power unit, that is APU, it is usually used in the ground services. It provides around 550 kilowatt. The third one is ram air turbine, RAT. It is used usually in emergency services like emergency hydraulic and electrical power. The fourth are the aircraft batteries which supply the electrical power. What are the alternatives of energy sources? First, hydrogen as a fuel. Second, fuel cells. Third, solar power. Fourth, alternative fuel like biofuel. Significant improvements in aircraft fuel efficiency are being achieved 1 to 2% per year, but annual aircraft air traffic growth is 5% is leading to an increase in CO2 emissions due to air transportation. This, along with aviation's strong dependency on fossil fuels, is driving research towards development on non-carbon based fuel technologies. Within the fuel cell and hydrogen technology sector, aircraft manufacturers are investigating the potential of PEMFC and solid oxide fuel cell systems to power light aircraft or as APUs on board commercial aircraft. Now, hydrogen as a fuel. Hydrogen as a fuel is too bulky. Also, it is not available in pure form on Earth. So, a lot of energy will be required to produce it in the pure form. It is a good option to be thought of, but not in the near future. Even we know that aircraft's weight is a much major factor because it flies in the air. So storing hydrogen in the fuel tank and carrying it for long distances won't be a good option to be thought of in the near future. The second option are fuel cells. They are really a good option. Now, what are the types of fuel cells? The commonly used fuel cells in aviation are two: PEMFC, that is polyelectrolyte membrane fuel cells, or SOFC, that is solid oxide fuel cells. How fuel cells work? Fuel cells require hydrogen and oxygen from air. Then from cold combustion chemical reaction they produce three things, that is water, inert gases and the most required electricity. Use of fuel cells in aviation. Till today, it is not possible to drive a passenger aircraft only with the help of fuel cell, but surely we can extract the use of fuel cell in small lightweight aircrafts and also to power some systems in civil passenger aircrafts. Use of fuel cell in small aircrafts. As you can see in the background, that is the aircraft which has been flown at 1000 feet from the ground with only use of fuel cells. This is the first ever flight of a manned aircraft powered by hydrogen fuel cells in February 2008 was both a milestone in flight history and an indicator of the advantages and possible limitations of fuel cells in airborne applications. Now let us look at a small video telling about fuel cell technology and its applications. Today manufacturers of various transport are interested in fuel cells using hydrogen and oxygen from the air as fuel. A fuel cell produces pure water and inert or inactive gases with no effect on the environmental and electricity. We may dream of flying a very light and silent plane, but for passenger transport we must be down to earth. The major problem over here is to produce and stock huge amount of hydrogen requires to drive fuel cell. But surely we can extract something else from these, like the fuel cells are used and have been tested to drive the hydraulic system of a passenger aircraft and the test went extremely well. After this, what more can be done to extract the use of fuel cells? We can use it to replace the APU which uses kerosene and is used for ground operations. This will provide noiseless and emission-free energy on board. The distilled water produced will fill the onboard water tank. The inactive gases produced will be used in fire protection systems in the engines. Ground operation will also be quicker, easier and cleaner. And we also won't need ground generators and water tankers on the ground. Now let's see one by one the multifunctional uses of fuel cell. First, in power provision in APU, emission free ground operation. We can also use it as autonomous taxiing, that is for taxiing on the runways. Maintenance bus supply, cargo reloading, electrical main engine start, EECS supply on ground, water generation, it is potable water and water for toilets and lavatories, heat generation, that is icing prevention, that is de-icing on the wings, explosion and fire prevention, that is with the help of the inert gases produced by the fuel cells, suppression, inerting of tanks, cargo and e-bay compartment. We can also use it as an electrical wheel drive to drive the nose wheel used in big airplanes. As seen in the video, they are used to generate the electrical power needed to supply the system of aircraft control and cabin comfort, and they power the hydraulic and pneumatic systems that operate the aircraft. Fuel cells can generate electrical power much more efficiently than conventional engine driven generators. One of the greatest advantage of using a fuel cell is that the water which is produced after the reaction can be used in galleys and lavatories of the aircraft. That reduces the water to be carried during the initial takeoff. Now what are the barriers and drivers for fuel cells? Drivers. They reduce emissions, it has a quiet operation, low infrared, good for surveillance in UAVs, improved fuel efficiency, weight reduction, byproducts produced can be used efficiently, that is water and heat and inert gases. Now what are the barriers? Technology needs to be proven. Still a lot of research will be needed to prove the technology. Hydrogen infrastructure, that is how to store the hydrogen, how to produce it, how to stock it in the aircraft is a big barrier. And the third and the most important is the high initial cost, which will be a barrier for many of the aviation companies to install it in the starting. The aircraft industry will not be an early adopter of fuel cell technology. However, given the interest in the technology displayed by the two of the world's major aircraft manufacturers, it is likely that fuel cells will appear in aircraft in the future. The most likely applications are hybrid fuel cell APU system for commercial aircraft, which with products appearing around 2020, and specialized military applications for surveillance like in UAVs, etc. Solar energy. If solar power is a highly promising renewable energy source for earth-based application, its use on aircraft has been limited because of the way such power is created and stored. While solar energy may be able to help a small aircraft fly, it is unlikely to be a practical solution for enabling larger commercial airlines into the sky. Now, how much power can be generated with the help of a solar energy? Power is energy upon time, which comes out to be weight upon glide ratio into speed. Weight is, we know, in terms of tons, speed is the average speed of the aircraft, and glide ratio, it is when the airplane's engines are stopped, how much it comes vertically down with respect to the horizontal distance covered by it. It has been seen that on a 747 plane we can apply around 12,000 solar cells on its wings. That's about 200 square meters of solar cells. Power from sun is 250 watts per square meter. Therefore, total power which can be attained on a 747 plane comes out to be 50,000 watts. The best commercially available solar cells are about 20% efficient at capturing solar power, and then there are further losses in the batteries, the electrical motors, so total efficiency comes down to be 12% only. So the power obtained is 6000 watt. A 747 has a glide ratio of around 12. From the power formula, a plane having wingspan as same as a 747 and having an average speed of say 12 meters per second would should weigh only 6 tons to fly with solar power. So 6 tons is a very small weight, so it is not feasible to apply solar cell and fly a commercial civil passenger airline plane, but we can use it for something else. So what are the future of solar power? The technology might take a giant leap forward with future advances, but today, even if an entire aircraft was covered with the most efficient solar panels available, this still would not be enough to propel it, but can be used for something else. For the more immediate future, solar power could provide electricity on board airliners once they reach the cruising altitude, or possibly help with ground operations at airport. Let's look at the fourth alternative, that is alternative fuels. It is one of the most important since everyone is concerned about fuel consumption to reduce the fuel consumption. Now, the industry is exploring reliable alternatives to conventional jet fuel that are sustainable and have a smaller carbon footprint. Now, what are the main requirements for sustainable alternative jet fuels? Firstly, it should be able to mix with conventional jet fuel, should use the same supply infrastructure and not require adoption of aircraft or engines. That is, we should not be it should not require to change the engine infrastructure, etc. Meet the same specification as conventional jet fuel, in particular resistance to cold and high energy content. It should meet sustainability criteria such as life cycle carbon reductions, limited fresh water requirements, no competition with food production, and no deforestation. And automotive bioethanol and biodiesel are not suitable for jet fuel. Sustainable aviation biofuels are one of the most promising solutions to meet the industry's ambitious carbon emissions reduction goals. Sustainable biojet fuels also allow airlines to reduce their carbon footprint, ease their dependence on fossil fuel, and offset the risk associated with high volatility of oil and fuel prices. Sustainable sources of biomass. Now, what are the sources? Biofuels should only be made from sustainable non-food biomass sources. Some examples include camelina is an energy crop that grows in rotation with wheat and other cereal crops. Halophytes thrives in salty regions where little else grows. Jatropha can be grown on degraded lands and in resistant to drought. Switchgrass grows quickly, needs little water and produces a high yield of biomass. Used cooking oil can be easily collected and recycled. Agricultural and forestry byproducts yield valuable biomass without requiring dedicated land. Municipal waste contains biomass and can be diverted from landfills. Now, the most important, algae. Algae are simple photosynthetic organisms. They can be grown in polluted or salt water, can produce up to 250 times more oil per unit area than soybeans. The value chain, the whole process from selecting a feedstock to the burning of the fuel in the aircraft. First, we need to select the feedstock according to the requirement and the area where we want to grow it. Then the feedstock growth. It will be grown wherever in land or water, whatever is feasible. Then the harvesting of the feedstock. Then the feedstock needs to be transported to an area where it would be refined and converted into biofuel. This biofuel produced will be taken to the nearby airport to store it and stock it. Then from the airport we need to fill the biofuel in the tankers, and this biofuel will be filled in the engines in the tanks of the aircraft, and it will be used to produce power. Now let us see, if we use algae as a feedstock, what are the requisites for producing biomass from algae? Firstly, the sun, CO2, nutrients. With algae produce biomass. The process. Photosynthesis is a biochemical process during which algae absorbs light energy from sunlight and carbon dioxide from the atmosphere or an industrial source. utilizes water and critical nutrients like nitrogen, phosphorus, and undergoes multiple step light and dark phase reactions to biologically produce primary lipids, fats and oils, carbohydrates and proteins, subsequently generating oxygen off gas. Algae production basically includes the sourcing of carbon dioxide, water, nutrients and light energy to photosynthesis system for conversion to algae of a specific composition. Carbon dioxide source. There are a number of potential carbon dioxide stack gas sources with high CO2 concentration preferable for algae production, including power plants and energy intensive manufacturing facilities. Water supply. Water provides the critical hydrogen source for photosynthesis. Various algae species thrive in freshwater or high salinity water environments. Certain wastewater streams containing high levels of nutrients may also be effectively utilized for algae production. Nutrient source. The primary nutrients required for the photosynthesis include nitrogen and phosphorus, sourced from conventional nitrogen phosphorus fertilizers. Light energy. Sunlight provides the main energy source for conversion of CO2 and water into algae. Generally, 70 to 85% of the total energy requirements, only the visible light portion of sunlight is useful for algae production, and more specifically, certain wavelengths are more efficiently absorbed. Now the algae composition. The composition of algae product is highly dependent on the specific species utilized and the photosynthesis operating conditions employed. Algae products contain from 45% up to 80% carbon content in the form of lipids or oils, carbohydrates, proteins, and hydrocarbons. Now let us look at a video telling about the production of algae and the process of making biojet fuels. Alternative viable to source oil is from industrial scale high yield growth system using an algae. Algae uses the sun, carbon dioxide and nutrients to grow. In a controlled environment, algae can multiply many times each day. Selected algae can produce 50% oil and 50% biomass, which converts to fuel products. This makes algae one of the world's valuable, renewable, and sustainable fuel resource. A look inside the technology shows how light, carbon dioxide, and nutrients deliver a powerful algae growth mix in a controlled and closed photobioreactors. The resulted algae is made up of valuable oil, sugar, proteins, and biomass. The algae is separated in oil and biomass. The products are separated to produce biodiesel, jet fuel, and ethanol. And the alternative fuels in practice that are which have been used and tested. Between 2008 and 2011, at least 10 airlines and several aircraft manufacturers performed flight tests with various blends containing up to 50% biojet fuel, and the 50% rest was the original jet fuel which is used in the daily process. These tests demonstrated that biojet fuel was technically sound, and the following observations were made. No modification to the aircraft were required. Biojet fuel could be blended with conventional fuel. The engine powered on the biojet mix even showed an improvement in fuel efficiency in some cases. The production and impact on net emissions. The main challenges to a wide deployment of biojet fuels are not technical but commercial and political. Currently, biojet fuels are significantly more expensive than Jet A or A1. Therefore, demand is low and risk is high for investment in production infrastructure. Carefully designed policy is needed to foster investment and development of biojet production capacity. A 3% volume blend in of sustainable second generation biojet fuel yearly worldwide would reduce aviation CO2 emissions by about 2%, which would be a reduction of over 10 million tons of CO2. This would require investment of around 10 to 15 billion in production and distribution facilities. The 5 easy steps to growing available aviation biofuel industry. Many of the technical hurdles facing aviation is its move towards sustainable aviation biofuel have now been overcome, and most of this work has been achieved within the industry. Now commercialization and scaling up of the supply of aviation biofuel is the most important task. Now this all has to be done by government. The role of government in these five steps are: first step, foster research into new feedstock sources and refining process. That is, new feedstock sources need to be developed. There are many different type of feedstocks and pathways that enable feedstock to be converted into biofuel, and important technological developments will unlock still more pathways. The industry is unlikely to rely on a single feedstock. Some feedstocks are better suited to some climates and locations than others. Several pathways are being considered for the development of sustainable aviation, biojet, and these are illustrated below. Here are below shown some pathways which can be used to select the feedstock. The second step, de-risk public and private investments in aviation biofuels. These incremental upfront capital investment costs are a potential barrier to commercialization. In this context, governments can play a role in reducing this risk through measures such as loan guarantees, tax incentives, grants, and co-financing for pilot and demonstration projects. They can also provide a level playing field with biodiesel by providing similar fiscal and price incentives in order to catalyze establishment of the sector. Third step, provide incentives for airlines to use biofuels from an early stage. Policymakers can foster development of aviation biofuel by recognizing the unique role it can have in reducing the aviation's environmental impacts. Aircraft cannot use alternative renewable energy sources available to other sectors such as plug-in wind, solar or hydroelectric power. Thus, crafting policies that create a level playing field for biofuels other energy sources and aviation with other sectors is a key element in aviation biofuel commercialization. Fourth step, encourage stakeholders to commit to robust international sustainability criteria. The development of an accepted set of globally harmonized standards will help ensure that investment is directed at biofuels from that meet acceptable sustainability criteria, thus minimizing this form of risk. Criteria needed to be mutually recognized around the world. For aviation, global standards are needed wherever possible. Due to operational routing of aircraft, common goal, equipment, and worldwide fuel purchasing requirements. Fifth step, establish coalitions encompassing all parts of the supply chain. Those seeking the those seeking to better understand potentials for this industry should engage with the process identified in this publication to understand next steps in each region. Advantages of biofuel: made with renewable resources, greener output, no mechanical changes required, end of fuel monopolization. Disadvantages of biofuel: energy output. Biofuels have a lower energy output than traditional fuels. Food shortage may become an issue with biofuel use. High cost. To refine biofuels to more efficient energy outputs and to build the necessary manufacturing plants, the cost is a major problem. Water use. Massive quantities of water are required for proper irrigation of biofuel crops. Now let us look at a new concept, that is smarter skies, for the saving of energy and CO2 reduction. The future of aviation concentrates on just that, and the Smarter Skies vision consists of three concepts which could be implemented across all the stages of an aircraft's operation to reduce waste in the system, waste in time, waste in fuel, and reduction of CO2, and would lead us to energy efficient aviation infrastructure. The three concepts are: first is eco-climb. Aircraft launched through assisted takeoffs using renewably powered propelled acceleration will allow for steeper climb from airports to minimize noise and reach efficient cruise altitudes more quickly. As space becomes a premium and megacities a reality, this approach will also minimize land use as shorter runways can be utilized. A continuous eco-climb would further cut noise and CO2 emissions, especially if renewable fuels were used, making the process even more eco-efficient. Second, express skyways. In the future, highly intelligent aircraft would be able to self-organize and select the most efficient and environmentally friendly routes. making the optimum use of prevailing weather and atmospheric conditions. High frequency routes would also allow aircraft to benefit from flying in formation like birds during cruise, bringing efficiency improvements due to drag reduction and lower energy use. In a V formation of 25 birds, each can achieve a reduction of induced drag by up to 65% and increase the range by 7%. While efficiencies for commercial aircrafts are not as great, they remain significant. As we can see in the figure, on the right side, a flock of birds forming in the V formation, and on the left side, the air concept airplane trying to form a V shape. Third, ground operations. On landing, aircraft engines could be switched off sooner, runways cleared faster, and ground handling emissions could be cut. Technology could optimize an aircraft landing position with enough accuracy for an autonomous, renewable powered taxiing carriage to be ready, so aircraft could be transported away from runways quicker, which would optimize terminal space and remove runway and gate limitations. Now let us look at a small video which will explain the working of the smarter skies. Fast forward to 2050 and intelligent planes could be propelled into continuous eco-climbs and flying formations along express skyways to cut time delay and emissions. The revolutionary view of smarter skies is the latest installment in the future by aircraft manufacturers. Assisted takeoffs would see lighter aircraft take off with continuous eco-climb from shorter runways and reaching cruising altitude faster. They could self-select the efficient route rather than today's zigzag flight patterns. Endeavor in mid-air before flocking light birds in the formation to reduce drag, increase fuel efficiency and minimizing emissions. They could pinpoint landing positions before entering the airport, gliding their way towards runway with their engines running in the idle position. The kinetic energy which is captured at landing might power onboard systems during taxiing. I hereby conclude the presentation by saying that in the near future the use of biofuel and fuel cell technology will be used at a vast scale, but a lot more research into it is needed. It is very important to look at more alternatives for the fossil fuels since they are depleting at very high rate. Also, the aviation industry has been successful in bringing the fuel consumption and CO2 emissions down by a great amount in the last few decades. I am sure this industry will also be successful in the coming decades to lead us to a energy efficient aviation infrastructure. Thank you.